Okay, let's start. So now see how to prove the theorem. How to prove the theorem. So in this case, we have three cases. We have three cases to prove the theorem. First one need to prove for positive integers, and need to prove for negative integers, and need to prove for rational numbers. Three cases. Okay. Then again, we use theorem to prove theorem again. We use same theorem to prove the theorem. Special property. Okay, now see this one. Proof of limit x goes to a, x to the power n minus a to the power n divided by x minus a equal n minus 1. Proof of this. Proof of the theorem. Now case 1 for positive integers. Case 1 for positive integer. Of n. Positive integer of n. Okay. Now see this one, factorization technique. So if you have x to the power 1 minus y to the power 1, we have factor x minus y, no? Then x to the power 2 minus y to the power 2, we have factor x minus y, x plus y. X plus y. Then x to the power 3 minus y to the power 3, x minus y, x square plus xy plus y square. Then x to the power 4 minus y to the power 4, x minus y, x to the power 3, x square y, xy square y cube, no? See here, power 4 we have factor x minus y. Start with power 3, x power decrease in y power increase in, all are positive. Then here power 4 we have 4 terms, power 3 we have 3 terms here inside this bracket, no? Then as x to the power n minus y to the power n, x minus y, x to the power n minus 1, x to the power n minus 2y, y to the power n minus 1. That's the pattern. So x power decreasing, y power increasing. All within 2 terms, positive here, the bracket. Then we know here number of terms n. Here for 4, number of terms 4. For 3, number of terms 3. For 2, number of terms 2. Then for n, number of terms n, no? Number of terms n. Then according to that one, we can factorize. Okay, now let's move to this. Let's move to this one. Now for positive integers. See. Limit x goes to a, x to the power n minus a to the power n of x minus a. Limit x goes to a, here x minus a, x to the power n minus 1, x to the power n minus 2 y, x to the power n minus 3 y square, it goes like that, y to the power n minus 1. Not y, no, that is a. Here into a square, here a to the power n minus 1 over x minus a. Now cancel this factor. Now we know here there are n number of terms, no? Thereafter, after cancelling this factor, that undefined case has gone. It has gone now. Then you can substitute. Substitute a to the power n minus 1, a to the power n minus 2 times a to the power n minus 3 times a square. It goes like that. A to the power n minus 1, you have to put at least 3 dots here because it is a series. No? Now, when you check here a to the power n minus 1, here add indices, again a to the power n minus 1, add indices, a to the power n minus 1, so on, a to the power n minus 1. Then all terms are a to the power n minus 1 terms. We know here number of terms n. Then similar type n terms, no? Then finally n into a to the power n minus 1. A to the power n minus 1. Then n a n minus 1. That is the proof of for positive integer. This is for positive integer, not for negative integer and rational number. Okay, do that proof. If you need to write this one, you can write. If you need to write these factors, I have given this one before. But if you need to factorization, just write this by the side. Then do this proof for positive integers. Okay. Now for negative integers, see this one. For negative integers, case 2. For negative integers, okay. Then for this case, now we have done for positive integers, no? We have done for positive integers, yeah, positive integers. Therefore, when proving for negative integers, the positive integer proof you can apply. Positive integer case proof we can apply, okay. Now, here limit x goes to a, x to the power n, a to the power n, x minus a, divided by x minus a. Then we know now here n negative integer, no? N negative integer. Then n negative integer mean you take here n value equal minus k. Say k positive integer. When k positive integer, k times minus 1 mean negative integer value, no? Negative integer. Then limit x goes to a, instead of n put minus k, limit x goes to a, then here minus k, no? 1 over x to the power k, 1 over a to the power k, x minus a. Then minus power mean take downstairs, change in sign. Then get common denominator. Limit x goes to a, here x minus a in denominator, x minus a in denominator, and take common denominator, that goes to again downstairs, x to the power k, a to the power k, and here this goes to a to the power k, and x to the power k goes to other side. Here it is now. Okay. Now k mean positive integer, no? K positive integer. Then positive integer proof we have done previously. Therefore you can directly apply for that. Then I'll write this one. Limit x goes to a. I'll rewrite, separate this part. 1 over x to the power k, a to the power k, into limit x goes to a, change minus outside, put minus here, and interchange these two. X to the power k minus a to the power k over x minus a. X to the power k, a to the power k over x minus a. Interchange these two and change the sign, and denominator, this part you separate. Now here k mean positive integer. For this part, positive integer proof we have done, no? Then apply theorem again. For this case you can substitute minus 1, put a to the power k, and for this apply theorem n minus 1, like this. For this part apply theorem. We are still on the way of proving that theorem, but anyway you can take that, because for positive integer partially we have done. The positive integer proof take. Now simplify. Minus k, a to the power k minus 1, minus here same basis, na? Then minus k, take these two upstairs. Then minus k, a to the power minus k minus 1. Then minus k mean n, no? Then say n minus 1. n minus 1. Instead of minus k, put n now. That's how we prove. Do it. Okay. Now we have done proof for positive integers and negative integers. Now for rational number. Then again we have done for positive integers, negative integers. Then for rational you can take both. Okay. Therefore, when proving this theorem, we have three steps, and we use same theorem again and again to prove the full case. Okay. Now let's move for rational type, rational number. See this. See this one clearly. Rational number. Okay. Here let n equal p divided by q, pq integers, q not equal 0, and pq doesn't have any common multiple. Here rational thing. That's the rational thing. Okay. Therefore, you take n value like p divided by q. Then for rational number we have property, no? We have properties. P divided by q type. See clearly. Then limit x goes to a, x to the power n, a to the power n of x minus a. Limit x goes to a, now x to the power n mean p divided by q. Further, limit x goes to a, I'll do this, say x to the power 1 over q to the power p. Here this power take outside. A to the power 1 over q to the power p, x minus a. Okay. Then I'll use substitution. Let x to the power 1 over p equal capital X. I'll take this one as capital X, and a to the power 1 over q, here 1 over q, x to the power 1 over q, a to the power 1 over q, you take capital A, 1 over q, capital A, 1 over q. Now you put here, then by this one you take power q, simple x equal x to the power q, simple a equal capital A to the power q. Then put capital X here, capital A here. Limit simple x goes simple a, here capital X to the power p, here this is capital A to the power p, simple x mean x to the power q, simple a mean a to the power q. Now that has converted up to that, x to the power p, a to the power p, x to the power q minus a to the power q. Okay. Then further, first write up this, Okay, I'll go a little further. Check this, check this. Now, up to now we done limit x goes to a, simple x goes to a, x to the power p minus a to the power p over x minus x to the power q minus a to the power q. Then by this substitution you say as x goes to a, capital X goes to capital A. Okay. Here as x goes to a to the power 1 over q, then a to the power 1 over q mean capital A. Therefore, as x goes to a, capital X goes to capital A. Then you change this limit, capital X, capital A. Then now divide by x minus a, both upstairs, downstairs, and separate limit. Like this. Now p mean positive or negative integer? No? P mean positive or negative integer. For positive integers we have done, for negative integers we have done. Then apply theorem, numerator and denominator. P a, p minus 1, here q a, q minus 1. Now we have to simplify. P divided by q, a to the power, here take this index upstairs, p minus 1 minus q minus 1. P divided by q, a to the power p minus q, a to the power p minus q. Okay. Then here p divided by q, take q outside, then p divided by q minus 1. Now, initially n equal p divided by q. Therefore, p divided by q mean n now. Then here p divided by q mean n. A to the power q. Here a to the power q equal a. A to the power q equal a. Here for this part a. P over q n minus 1. That is for rational number proof. Then first you prove for positive integers, then you prove for negative integers, then you prove for rational type. Okay. Now do complete proof. Okay. Now let's move for another case. Let's move for another case. Write down. Write down. Limit evaluation. Limit evaluation. Limit evaluation as x goes to plus infinity or x goes to minus infinity. Limit evaluation as x goes to plus infinity and as x goes to minus infinity. Okay. Usually limit exam question will be with trigonometric functions, and sometimes that can be included irrational expressions as well. Okay, this part not belongs to limit question in our A-level limit question, but this is very important part for differentiation graph. And again there's another part for question number 12 series, convergence check, convergent divergent series check. Okay, then see this one, limit x goes to infinity x plus 2. See this. So when you substitute infinity plus 2, it is infinity. No issue, we can directly substitute for this case. Then limit x goes to infinity 1 over x, then 1 over infinity 0. 3. Limit x goes to infinity minus infinity 1 over x, 1 over minus infinity 0 again. No? 0. 1 over infinity, that goes to 0. That can be plus or minus infinity, both. Fourth example, limit x goes to minus infinity, say plus infinity, x square plus x plus minus 1. Substitute infinity, then infinity square infinity, infinity plus infinity infinity, infinity minus 1 infinity. Then infinity possible answer. Okay, minus infinity to plus infinity possible answers. Only undefined expressions, 0 by 0, infinity by infinity, 0 times infinity, 0 to the power 0, infinity minus infinity. They are undefined, but infinity possible solution. Question number 5. Limit x goes to infinity, x square minus x plus 1. Let's see what will happen here. Substitute infinity, then infinity square minus infinity, mean infinity minus infinity. This is undefined. Then that path not okay. Infinity minus infinity undefined. Then that path not okay. Then now here onwards we need different technique to evaluate that. Here the way. You take maximum power outside from the bracket. Maximum power x square, no? Take it outside. Then here 1. X over x square mean 1 over x plus 1 over x squared. No? Take x square outside. We can't get x square outside from the limit. We can take only the bracket. Take outside from the bracket only, because x is a variable. No? Now you substitute infinity, then 1 over infinity, that goes to 0. 1 over infinity square, that goes to 0. Then substitute infinity square, 1 minus 1 over infinity, 1 over infinity square. Now here this part 0, this part 0. Then 1 minus 0 means 1, 1 times infinity square, infinity. That's how we evaluate. Then here another different technique, different case of evaluating limit. Okay. First write this. When the variable x goes to plus or minus infinity, when the variable x goes to plus or minus infinity, when the variable x goes to plus or minus infinity. As first step, as first step, substitute infinity for x. Infinity for x. Then any value in between minus infinity to plus infinity, then any value in between minus infinity to plus infinity can be taken as the solution. Can be taken as the solution. Okay. Now you do up to question number 4. Do up to 4 only. Don't write fifth one. Do up to 4 only. With star mark write down. For undefined expressions, better take maximum power term outside from the bracket, from a bracket. For undefined expressions, better take maximum power term outside from a bracket. And do simplification, then substitute infinity for x. Okay, do question number 5. Do question number 5 now. Okay. Now let's do further few examples. See this now. See this. Limit x goes to infinity, say minus infinity, 1 over x square minus x. Then don't substitute directly now, because when you substitute infinity directly, but here okay, yeah? But here this case okay. So when you substitute minus infinity, we get this. Infinity plus infinity, here 1 over infinity goes to 0. Answer 0. This is okay. Okay. So in your mind you substitute x infinity, then simplify. So whether we get minus infinity plus infinity value, take as solution. But for other cases, you take maximum power term outside. Yes, sixth one. Seventh one, limit x goes to infinity, x square minus x. So here when you substitute directly, 1 over infinity square minus infinity. No? It is undefined. Infinity minus infinity undefined. Undefined. So we can't take as solution. No? So the procedure here, limit x goes to infinity, take maximum power term outside from the bracket. Here maximum power term x square, take outside. Then here this will be 1 minus x over x square means 1 over x. Thereafter substitute. Then 1 over infinity square 1 minus 1 over infinity. Then 1 over infinity, that is 0. Then here 1 minus 0 1. 1 times infinity square infinity, 1 over infinity 0. 0. Okay. Then you have to remember 1 over infinity, that goes to 0. 1 over minus infinity, that goes to 0. Then infinity square equal infinity. Infinity times 2 infinity. Infinity plus or minus 1, they are infinities. All are infinities. Okay. Do those examples. Do them. Okay, let's do further few examples. See this one all. Take this question number 8. Limit x goes to infinity, x square minus 2x plus 1. So when you substitute infinity, we have problem. When you substitute infinity, we have problem. That is infinity minus infinity will be appear. This is undefined. Therefore, you take maximum power term outside. Limit x goes to infinity, 1 minus 2 over x, 1 over x square. Now substitute infinity. Here goes to 0, goes 0. We get answer infinity. We get answer infinity. Question number 9. Limit x goes to infinity, 1 minus x square. You do same thing. Take x square outside, then here 1 over x square, 1 over x plus minus 1. Now substitute infinity. Before you take outside, when we substitute it, we get undefined expressions. That's why we take maximum power term outside. Now substitute. Now check, here 0, here 0, infinity square infinity times minus 1. Then answer minus infinity. Minus infinity possible answer. 10. Limit x goes to infinity, x square plus x minus 1 over 2x square minus 1. See, you take maximum power outside, both upstairs and downstairs. Take x square outside. Take x square again. Simplify, then substitute infinity. Then 1 over infinity goes to 0, 0, 0. Then 1 over 2, answer half. See? Then identify. Better to take maximum power outside and do simplification. Thereafter, again substitute infinity. Okay, complete them. Complete those examples. Okay. Now you try page number 3. Question number 8. First try question number 8. Page number 3, question number 8. I'll give you a little time. Complete. Okay, question number 8. Limit x goes to infinity. First part. X to the power 5 minus x. Take maximum power outside. Then substitute. One over infinity to the power 4, 0 plus infinity. 2. Limit x goes to plus infinity, x to the power 4 minus x. Take maximum power outside. Then 1 over infinity goes 0. Answer infinity. Question number 3. Limit x goes to infinity, e to the power x, x to the power 5 minus 5x. Here there's ex term. Then I'm going to separate that first. Limit x goes to infinity, ex. Limit x goes to infinity, take maximum power. Then substitute e to the power infinity times infinity to the power 5 e mean irrational number 2.7, around 2.7. Then 2.7 to the power infinity, surely infinity. Yeah, e mean around 2.7, approximately 2.7. Then 2.7 to the power infinity, infinity. So this goes to infinity. This goes to infinity. Here this goes to 0. Then infinity times 1. Answer infinity. Answer infinity. Take time further. Take time. Now with that, better to put this note. Check this. 2 to the power infinity, that goes to infinity. Then value greater than 1. Then half to the power infinity, that goes to 0. Again check. A to the power infinity, a greater than 1, answer infinity. A less than 1 answer, 0. For fractions, fraction means less than 1 value. Less than 1 means positive less than 1 value. 0 to 1 value, we get answer 0. For greater than 1 value, we get answer infinity. A equal 1 case, 1 to the power infinity, here this is we say undefined again. Undefined. Then you just remember, value greater than 1 to the power infinity, infinity. Value in between 0 to 1, infinity, 0. 0. Not. Okay. Therefore, e to the power infinity, infinity. E to the power minus infinity, 1 over e to the power infinity, that goes to 0. Here goes to 0. Goes to 0. Then 2 to the power infinity, 2 to the power minus infinity, 1 over 2 to the power infinity. that goes to 0. 1 over infinity, 0. Okay, these are infinity cases. Then 1 over 2 to the power infinity, that goes to 0. 1 over 2 to the power minus infinity, here for minus you take reciprocal, that goes to infinity. Then 1 over 2 to the power minus infinity, it is 2 to the power infinity, that goes to infinity again. Better to put this note, huh? Better put that note. If you have completed question number 8, try question number 7. Only 4, first 4. Question number 7, only 4. First 4. Huh? Okay, then question number 8, remaining 3. Limit x goes to infinity, x to the power 4 minus x square, here fourth one. Take x to the power 4 outside. Then substitute infinity. Question number 5. Limit x goes to minus infinity. Take x to the power 8 outside. Then substitute. Here 0 plus infinity. Question number 6. Limit x goes to infinity, e to the power x, 2 times x to the power 4 minus x. Separate limit first. And same time get maximum power outside. Then substitute. Here 0, infinity. That is question number 8, remaining part. Try question number 7, first 4 questions. දැන් මම මේ මගේ මෙහෙම ප්‍රශ්න ටිකක් අහපින්ද මම පොඩි දෙයක් කියන්නම් බලන්න. චුට්ටක් බලන්න මෙහෙම බලන්න. දැන් මම සමහර තැන්වලදී මෙහෙම දෙයක් කිව්වනේ. මේක මෙහෙම කිව්වා. 1 to the power infinity undefined කියලා අපි ගණන් ගන්නවා කියලා කිව්වානේ. එහෙම මම කිව්වා. 1 to the power infinity undefined. ඒතර ඔයාලට 1 over 2 to the power infinity දැන් මෙහෙම හිතුවොත් 1 to the power infinity 2 to the power infinity. මෙහෙම හිතුවොත්. ඒතර එතනදී අපිට මෙතන undefined මේක defined. infinity මේ value එක infinity මෙතන undefined. එතන මේකට කොහොමද 0 එන්නේ කියන එක. මේක කොහොමද 0 එන්නේ කියන එක. අපිට මේ ඉන්ෆිනිටිත් එක්ක වැඩි සෙල්ලම් කරන්න බෑ. හරිද? ඉන්ෆිනිටි අපි දන්නේ නැති කෙනේ. ඉන්ෆිනිටි අපි දන්නේ නැහනේ. ඒතර ඉන්ෆිනිටි කියන එක ඩිෆයින් කරලා තියෙන්නේ නිකන් very large එකත් very large value කියන එකත් හොඳ නැහැ. very large value කියලා අපි කිව්වට ඒකත් හොඳ නැහැ. හරිද? ඒතර නිකන් ඉන්ෆිනිටි කියන එක නා දැක්කහම අහක බලාගෙන යන්න ඕන කෙනේ. අර එයත් එක්ක සෙල්ලම් කරන්න වැඩි බෑ. ඒතර අපි දන්න කේසස් ටික කර යන්න ඕනේ. හැබැයි අපිට මේක තව ඩීටේල් කතා කරන්න පුළුවන් graph එකට යනකොට. එහෙනම් ඔයාලා දන්න general algebra වලින් අපිට මේකට යන්න පුළුවන් පොඩි part එකක් තියෙනවා. හරිද? අපි දන්න general algebra වලින් discuss කරන්න ඕනේ පොඩි part එකක් තියෙනවා. ඒ ටික ගැන විතරයි මම මේ කිව්වේ. මෙතනින් එහාට හිතන්න යනකොට algebra එක්ක conflict එනවා. ඒ කියන්නේ අපේ තියෙන algebra එක conflictions එනවා එක එක. එහෙනම් ඒක අපි නැති කරගන්න අපි ඊළඟ try කරන්න ඕනේ graphically යන්න ඕනේ. අර බලන්න y equal 2 to the power x 2 to the power x graph x y මේ x ට values දදා ගන්න x0 දාද්දි 1 මේ values දදා plot කරලා ගත්තොත් ඒකේ graph එක වෙන්නේ මෙහෙම case එකක් එනවා කියලා තමයි අපිට පේන්න ගන්න. ඔන්න ඔතනින් තමයි කතාව හරියටම කියන්නේ. x goes to plus infinity y goes to plus infinity. X goes to minus infinity, y goes to 0. That goes to 0. Therefore, limit x goes to plus infinity 2 to the power x goes to infinity. Limit x goes to minus infinity 2 to the power x that goes to 0. මේ graph එකත් එක තමයි එන්නේ. එතකොට අර terminal tendencies ටික තියෙනවා terminals ටික. එතකොට terminals ටික අපි මෙහෙම යනවා කියලා නිකන් හිතනවා විතරයි. අපි මේක මෙහෙට ගියොත් මේක මෙහෙම යනවා කියලා guessing එකක් විතරයි මේ තියෙන්නේ. ඔය guessing එක වැරදින්න පුළුවන්. අපි ඕක ඒ level එකට zoom කරලා බැලුවොත් සමහරට ඕක කියා ගන්න බෑ, හිතා ගන්න බැරි මේක මෙහෙම ගිහින් ඔහම යන්නේ නැතුව පොඩ්ඩක් නිකන් කැරකිලා නිකන් ඉන්නව වෙන්නත් පුළුවන්. එහෙම වෙන්න පුළුවන්. හරිද? එහෙනම් අපේ දැන් යන maths වලින් අපි ගන්න ඒවාලින් අපි දැනට මේ වගේ tendency එකක් තියෙනවා කියලා ගන්නවා. නිකන් ආයෙ තව just example එකක් කිව්වොත් දැන් අපි රත්තරන් තියෙනවානේ. රත්තරන් අපිට මේ වගේ සාමාන්‍ය මයික්‍රෝ ලෙවල් එකට යනකොට ඒක රත්තරන් වල ප්‍රොපර්ටිස් නැහැ. ඒ කියන්නේ ග්ලෝබල් ප්‍රොපර්ටි නැති වෙලා යනවා. හරිද? අන්න ඒ වගේ එහෙම කතාවක් තියෙනවා. ඒතකොට මේකේ අපිට පේන්න අර වගේ කතාවක් තිබුණාට ඇක්චුවල් කේස් එක වෙනස් වෙන්න පුළුවන් පොඩ්ඩක්. දැන් 2 to the power x මෙයා half to the power x graph y equal half to the power x කියන එක. එයාගේ graph එක එන්නේ 1 over 2 to the power x. එයා එන්නේ මෙන්න මෙහෙම එන්නේ. මේක අනිත් පැත්තට හැරෙනවා. එතකොට x goes to minus infinity y goes to plus infinity. x goes to plus infinity y goes to 0. 0 tendency එකක් තියෙනවා. හරිද? එතකොට අපි ටිකක් තව ටිකක් detail discuss කරන්න පුළුවන් graphical method එකට ගියාම. එතකොට මේ limit කියන එකේදී අපි discuss කරන්නේ අර වගේ tendency එකක් ගැන. මේක මෙතෙන්ට යනකොට අරයා කොතෙන්ද යන්නේ කියලා තමයි ඒ කියන්නේ ඒකත් එක්ක තමයි මේ evaluation එක කරන්නේ. හරි. අර questions 4 විතරක් අපි ඉවර කළෙමු. Okay. Now question number 7 part 1 first part limit x goes to infinity x square plus px plus q x square plus mx plus n. Limit x goes to infinity, take maximum power outside. දැන් මෙතන දුන්නත් ඔයාලා මේකට සබ්ස්ටිටියුට් කරත් වැඩේ අවුල් යනවා. මේක කැන්සල් කරලාම කරන්න ඕනේ. ඒක කැන්සල් කරලා තමයි සබ්ස්ටිටියුට් කරන්න ඕනේ. එතකොට එන්නේ 1 plus p over infinity 1 over infinity square m over infinity n over infinity square. Here cube. Then 1 over infinity is 0, answer 1. Answer 1. ඔයාලා මේකට සබ්ස්ටිටියුට් කරලා මෙතන ඉන්ෆිනිටි ස්ක්වයර් over ඉන්ෆිනිටි ස්ක්වයර් දාලා ඉන්ෆිනිටි දෙන්න කැපුවත් ඔය ආන්සර් එකම එනවා. ඒ වුණාට ඒක වැරදි ඈ. ඒ කියන්නේ මේක x කෙන් දා කැන්සල් කරන්න පුළුවන්. x කැන්සල් කරලා දාන්න පුළුවන්. හැබැයි ඉන්ෆිනිටි දාලා ඉවරලා ඉන්ෆිනිටි දෙන්න කැන්සල් කරන්න බෑ. අර ඒක පොඩ්ඩක් වහගෙන තමයි යන්නේ එතන. පොඩ්ඩක් ෂේප් කරගෙන යන්නේ එතන. මේක කැන්සල් කරලා දානවා. ඒ කියන්නේ ටෙන්ඩන්සි එක චෙක් කරන එකයි කරන්නේ. ඒතර අපි ජෙනරල් ඩිරෙක්ට් ඇල්ජිබ්‍රා එක ඇප්ලයි කරේ ගමන් වැඩේ අවුල් වෙනවා. ඉතින් ඩිරෙක්ට් ඇල්ජිබ්‍රා එකට පයින්න එපා එතනදී. ඒක අර කැල්කියුලස් කියන්නේ ඒකයි. කැල්කියුලස් කියන එක අයිඩියා එකක් තියෙන්නේ. ඒ අයිඩියා එක අරකට එක්ක ටැලි වෙන තැන් තියෙනවා, ටැලි වෙන්නේ නැති තැන් තියෙනවා. ඒකයි ඇල්ජිබ්‍රා, කැල්කියුලස්, කෝඩිනේට් ජියොමෙට්‍රි කියලා එහෙම sections එන්නේ. Okay. Then second part, limit x goes to infinity ax square bx plus c cx square bx plus a divide by x square zero 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 a over c. Okay, then third, limit x goes to infinity 3x square 5x plus 7 5x square 7x plus 9 3 5 over x 7 over x square 5 7 over x 9 over x square 3/5. Fourth, limit x goes to infinity x cube 2x square 3x minus 4 3x cube 5x minus 2. Limit x goes to infinity 1 2 over x 3 over x square 4 over x cube 3 5 over x square 2 over x cube. Answer 1/3. 1/3. That property, this property we will apply directly later, but for now just get solutions by that technique. Okay, completed. Okay. එනා ඒ ලිමිට්ස් පාර්ට් එක දැනට ඇති. තව ඒ වුණාට යන්න තියෙනවා ඊළඟ දවසේ අපි සෑහෙන දෙයක් ඉවර කරන ලිමිට්ස් වල. මේ එහෙනම් ඒ කොටස එතනින් ඉවර කරන්න පුළුවන්.